Swayam Prabha. Digital India. Educated India.
What is Dr. Dharmi an expert of? Wow, you know, huh? Okay, he is going to keep here and he is going to challenge me. What's the challenge?
Can you hold it?
Let's see. Oh my God.
Fell.
You can hold it. Take your pen and do it. Let's see if you hold it.
Sir.
Wow. But one condition. You can hold only like this. You can hold the paper only like this. I don't know. You can hold it like this only. You can hold it like this only. No, only like this. Like scissors. Challenge. Fast. Challenge.
Did I read it?
No, you folded the. No, this is not folded. You can fold the other side, but not here. Look at it. Nice. Regular. He gets a chocolate. Okay, folks. One thing that happens to you. So, listen to me today. Talk later. When I asked you to do, one thing that you did was to curve it. Correct? And then it became easy for you to hold anything. Correct? Now, why didn't it hold when I held like this? Why didn't it? Now you are silent. Raise your hand and answer. Why is it that if I hold like this and put it, it doesn't happen? But the moment I do like this and keep it, I can hold it. Why?
Because you don't have a stiff base in the other case, but you have a stiff base.
Very good. Okay, so I need a volunteer. Come first. We're going to do some experiment and you will answer. I can put it off, no? Body was loose in the first thing. Any other? Thanks, ma'am. Give him a hand here. Give him a hand. Yeah. So, you said, can't hear you. He was pushing back.
Your leg position.
Leg position.
You bend forward to like.
What do you attribute to me the first scenario and the second scenario?
So in the second scenario, you knew he was going to push you, so you slipped your muscles so that he could help you.
And therefore, what was I doing? I was.
Your foot was placed over.
Yeah, your foot was widened your parted leg. to the ground.
The first time I was.
More force to the ground.
The first time I was.
More resistance to the second.
Come. What's your name?
Nihal.
Can't hear.
Modi.
Come here and tell me.
Modi.
Ah. Now he's going to tell me.
Nihal, sir.
Oh, Nihal. Okay. Watch the same scenario. Don't push him too hard. Keep pushing.
Okay. Back leg is more.
Okay. Okay. Now again.
They push with some force.
Second scenario. Okay. What was I in the first instant and the second instant? Thanks, Neha. Yeah. Let's see. Chocolate answer. Okay. I need a word. I need a word. Or in other words, what was I in the, I'm Shiva, that's a different story. What was I in the first scenario and the second scenario? Chocolate answer. One word. Huh? I was not resisting. What do you call somebody who is not resisting? Okay, I'll give you a clue. Do you need a clue? The first letter of that is F. Huh? Flexible. Give me chocolate. The second one does not need a chocolate. What was the second scenario? Or stiff. So, if you look at any material, the one that you had here, when you wanted to keep something here, it fell because it was flexible. Correct? The moment I did this way, the same paper, material is the same. It could hold because it was stiff. So, what we understand from this is when we curled it, we changed the geometry of this. Yes or no? Yeah? For example, like what Kavya did, take this and make it into fan-like. So, fold like this, like this, like this. Go ahead. Yeah, you fold like this. Not the way that you have done. Only lengthwise. Only lengthwise. Go ahead, quickly. Already 15 minutes lost. No, fold as many so that it becomes like a fan. No? Fat. See, you have to become experts with your hands. You should be able to think with your hands. That's one skill that is necessary for an inventor. Okay? In the next class, I will be talking about the mathematics that you need for an inventor, by the way. Okay? Like this, like this, like this. What shall we call this as? COR, corrugated. This is a corrugated sheet. And when I have this corrugated sheet, I know it is stiff enough. Correct? Where do you see it? Some of the sheds, right? Some of the sheds, because you have thin sheet. If you put it as thin sheet, it will start to sag. It may be a good idea to do this. So what we understand from this is, if I change the geometry of the material, it helps in terms of tuning the stiffness. For example, one of you did like this, one of you did very thin like this. See, this is very thin compared to this, correct? Which one will be stiffer? This one is stiffer, correct? The reason is the distance between the top and the bottom is more, right? That's the observation. We are not still understanding it, it's just an observation. And when I put this weight over here, what action is happening? What action, for example here, when I put this, what action is happening? Bending, correct? And therefore the stiffness or the flexibility is associated with bending. Very good. Here also it's the same, right? This kind of structure helps in terms of increasing the stiffness, and depending on the height, it will be higher stiffness or lower stiffness. But what happens is, I want you to do this experiment, just hold nicely at one end and bend it as much to see where it is failing. Bend it as much possible and see where it is bent. Quickly. Just put weight on the end while holding one side as much so that it fails.
Bending either holding.
It fails. Look at me. It fails.
Bending at the point
It
where
fails. Correct? Yeah? While we'll talk about why it fails at the point where you're holding, you will notice that the top and bottom are critical. Yes or no? If you do that, you will see that the top and bottom actually buckled. Are you with me? Another example that I can show you is, this is something that all of us know, right? 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 This is just foldable. But on the other hand, the moment there is this curvature, you are able to stretch it as much as possible. Very nice example of geometry playing a role in terms of increasing what stiffness? What action is this? Bending stiffness. Are you with me? Later on, I am going to ask you about the other possibility. Okay, but we will come to that. Is this clear now? What we will do is, the moment we do this geometry change, what we are actually doing is we are creating a material. If it is at a micro level, we are creating a material which is called META material. Did anybody talk about it in these lectures? Not yet, huh? Okay. We call it as metamaterials. I can tune the stiffness appropriately. There are other properties also I can tune, right? But one property that we learned today is that I can tune the stiffness, right? But on the other hand, if I bend it the other way, is it stiff enough? Which means that I need to have something similar to this the other side, correct? The one way that I can do is open it and fold it the other way, but that's not going to help. Maybe I'll tear it off into strips, put one strip this side and one strip that side, correct? What I basically made is a cellular material, correct? Cellular material has cells all around. You have seen cellular material, right? The one that we are going to experiment with is that kind of arrangement. This is something that you are capable of doing on your own. We have just done this so that for want of time, all right? What you see here is whether I bend it this way or this way, stiffness is good enough. But the problem is when I bend too much, what happened there would happen over here. If I have to prevent, what should I do? Remember, at the top and bottom edge, it is giving way. I need to add something so that it doesn't allow, correct? So what we are going to do is, you are going to do this experiment by yourself. We are going to cut pieces and give you. You stretch it like this, for example. You stretch it like this, okay. Since it's not enough, it has good stiffness, but it's not enough. What you will do is, I'll give you the sheet. Two people, one sheet, okay. Either you can do it as a group or otherwise, it doesn't matter. It may be a group activity if it is possible for you. Just bend it, tear it, give it to the other. Now here, if I put one on top, one sheet on top and stick it. What I have done is I have given an additional support, correct? And if I do the same thing the other side, maybe it will be very stiff, correct? Maybe it will be, but why should I do this? Why should I do this way? Why should I do this way, etc., etc.? Why? What is the benefit? What is the, what's the benefit? Distributes the pressure. What's support is correct. Why at all? Hey, I can take like this now, over, stiffer. Why am I doing all this? I can take a block of metal piece over. See, look at this wood, like that, no? Huh? Lightweight. See, the reason why we want to do that is the weight should not be high, right? So now we are talking about stiffness, we are talking about weight for weight, stiffness, weight. What shall I do? 2 parameters. You always been doing this in my class. What is that called? Specific stiffness. Wonderful. Specific stiffness is what we are talking about. Alright? If the specific stiffness is high, then the amount of material that I have used is less. Stiffness for that amount of material, it could be mass or volume, is high. Are you with me? Right? Why do I need? I need highly stiff materials, but lightweight. Where do you think we will apply that? Whatever flies, correct?
Sir, but you're just bending it, right? So how is it making anything lightweight?
Lightweight for bending stiffness. I'll give you an example. You can go and check it out also. Most of you may be probably vegetarians, but if there are non-vegetarians, be friends with them so that you can check out the bone of a bird. Tell me one bird that people eat. Chicken. So if you look at the bone of that will be hollow. The reason why it is hollow is lightweight. And when it is doing like this, it has to be stiff here, correct? It should be stiff here. Are you with me? Just follow because time is short. Right? So, and therefore, geometry now helps me. Clear?
So
Yeah.
he's non-veg and he's telling that chicken won't have marrow.
Yeah, okay. Well, in bone, 2 people have graduated with the PhD in bone with me. Bone has two layers. The outer layer, which is called the cortical bone, is a stiff material. Inside is a sponge. That's called the marrow. The reason why it has sponge has other functions that come about. But cortical bone is stiff enough, like what we see here. Are you with me? What we understand so far is geometry matters. Okay? Now quickly, I need a volunteer. This is too much. Half of it is fine. 2 people can use this. I need volunteers. 1 from this side, 1 from this side, 1 from this side. Yeah, here. Come. Where is he? Somebody tell me the time? 9:34. Good. I don't know how much we can do. Go ahead. Here.
Three, sir.
Hmm? Yeah. It's not necessary that only one per group, but yeah, I need your help on this one. Yeah, one of you come.
So 1.3 people.
Come over. Come, ma.
One per group.
Come. Okay, here. You distribute one Fevicol per group. Thank you. Yeah? No. Yeah. It's not necessary that you should have only one per group. One more volunteer, please. One more volunteer. Yeah. So take these sheets, pull it out. Okay. Give it enough. One per group.
Sir, I just gave 3 per group. I get 3 per group.
That's okay. Yeah, here. Anybody needs more? Distributed, no? Okay. Anybody needs more? You need one more? No, you got 3.
Thank you.
Done? You have enough?
Yes.
You have enough? Yeah, okay. Now, each group will get a glue bottle. Just pass it on. Raise your hand if you don't have glue. No, just pass it on. Pass. Very good. Thank you. Now, what do you use this for? So what I need you to do is, you will now dirty your hand. Freeze! You will dirty your hand. The first thing you will do is stretch it enough. Don't tear it, but stretch it enough. Once you have made it into square-like stuff, cut square pieces from the cardboard sheet that we have given and apply enough Fevicol on it. Alright? Let it dry a little bit before you stick it onto this. Alright? Are you with me? One at this side, one at the other side. Like this, one to this side, one to this side, and then test out its stiffness. But not now. Yeah. So what I want you to do is start now. Just tear a square piece appropriately and use the Fevicol. Dirty your hand.
Not this. You have to sandwich it.
So that's called a sandwich panel. So you stretch it like this, cut a sheet like this, tear a sheet like this. You need a sheet. Is there one more Fevicol? Thank you. Yeah, I'll take it. Go ahead, folks. Time is short. You need a sheet also.
Instead, if we use it in real life, sir, we'll be using a metal mesh and a metal plate, right?
Right now you'll use it.
No. In real life, if we are using, but instead of using a metal plate, won't it be easier to use like 2 metal sticks?
We'll come to that.
Easier
I'll tell you.
and stiffer, right?
Not really. I'll tell you.
So 3 metal sticks. Scissors.
No, just tear it like this. You already know how to fold nicely, form a crease and tear. within the next 10 minutes you have to do, so that the next activity is making a ball, having a ball. Very good. Everybody is in action. Yeah. Crease. So use this one, crease. Use this. Very good.
Hey, we don't talk about it.
Use this, no? Easy. Good. Not feeling well? Okay. She is feeling C instead of well. What kind of tearing is this? Like that. Correct. Very good.
Later it is possible that you can even stand on it. Still they will hold your weight. That's the paper.
Okay, good. Come on. See, you fold like this and the other way around, makes it easy for you to tear nicely. 4 more minutes. So you are going to show after they make the soft ball, you will show because time is short.
No, we can show just we are sticking with the stiffness so we can do it.
Yeah, okay.
Then again to introduction,
You're correct.
we are going stiffness and so.
Yeah. Put enough glue, don't immediately put it on it, wait for it to dry a little bit. The drying a little bit is very important. All of you would have learnt it in your art class. No? To become an inventor, you please join an art class, craft class. Alright? Yeah, glue should be on the paper. If you can just softly lay it on the top and bottom of the corrugated sheet, it will be very nice. It will stick much better. So take the Fevicol, you dirty your hand and apply a little bit here and here also. Don't stick it immediately, wait for it to dry. And don't experiment with that immediately. Experiment you will do after the next lecture is over. Because it has to dry up. Fevicol takes about an hour to dry up. So you need to wait patiently. Else you will become a patient. It will be stiff and strong. Where is the other one? Who has taken the other one? Okay. Yeah, folks, pass it on. This is what is used in the rockets. So this was obtained from ISRO.
Sir, how much will that sell for, sir? How much will it sell for?
No, this just I got it from ISRO. Just pass it on. Try and bend and see. And if you just press a little bit, you will know how soft the inside core is.
So like what's the material?
And the aluminum. Not necessary.
Expensive.
Not necessary for this.
So like what is it used?
This is used for outer shell of the rockets so that it is light.
Yeah, it's all available. You can buy it.
You can buy, I don't know about metal, but you can buy the sheet form. You can buy something like this. Yeah, 5 more minutes, folks, because we have a lot of experiments to show. 9:40, yeah? Oh, it's here. Oh my God, 9:45. Madam, difficult to get 5 more minutes, no? So all these have to go back. Three more minutes.
Not on the sides, just on the top and bottom.
They are video of the.
Done? Folks, what you are making is a meta material. This is at a macro level a meta material. Same thing can be done at a micro level. So that the material that you come up with is lightweight as well as stiff. Okay. Don't test it out right now. Keep something on top and bottom, or just keep some weight on top so that it nicely, it can be your water bottle or whatever. Place it somewhere. Please experiment with this only after the next lecture is over. Alright. Once you are done with your Fevicol, what's your name? Kirtana will collect the Fevicol and give it to us. Now, having done this, how many of you are yet to do? Yet to complete? Yeah. If you have a notebook or something, just pull the notebook and keep on top of it as weight. If you what? I can't hear you. Dabbu? You don't have Fevicol at home? Huh, really? Why not, dear?
3,000 stipend they are giving to Fevicol.
What stipend? Pocket money, not stipend. Yeah. Mom and dad, you have to be very good friends with them. Hey. How many of you get pocket money? Wow, okay. Okay, folks, shall we go to the next one? All right, pull out your socks. Pull out your socks. Give me one of them. This is the thinner version. Pass it on.
So this was used.
Huh?
It was used.
So just to give you an idea of how soft the core is, and pass it on. Folks, we have very less time, so pull out your socks. I need one socks to just demonstrate to you. Any, yeah, throw. All right. Yeah, so please note, there should not be any hole at the tip. Make sure it is not having any hole at the tip. I need 2 volunteers here. Come over fast. This is, I'll just demonstrate, have a look at it right now. Fold it like this, get to the tip of the socks. Just one fistful, you pour the wheat into, make sure it is inside like this. Do you see? Do you see it? Yeah. If you need bigger ball, you will have to put a little bit more. Okay. So I'm just containing it only this much. We will distribute this to you. Distribute. One per person. Yeah. What you do is very simple. Just listen to me carefully. Make sure that all the wheat is at the edge. Tie it. Okay? Tie it. I am hoping that all of you know how to tie. Okay. So do that. I have now tied it. I have now tied it. What you do is put your hand into it, reach out the edge of it, put it like this and take it out. Okay? Again do the same thing. Go on doing it. So you put your hand again and look at what I am doing. Like this. Hold it. Put it out. You will see like this. Okay? And keep on doing it. You will get a ball. The ball, just touch it, is squeezy, which means soft. You want to play a game where even if you throw on to a person, it doesn't hurt. Very nice. Something that you want to play, but it shouldn't just roll away. Nice. How many of you have played 7 stones? Wow. You can play nicely with this because it doesn't hurt you. Right? And it can definitely it can definitely displace the stones. All right? Okay, quickly start with one of you can go. Give this, leave your socks. Okay, they are going to pour into your socks as much as you need. One is enough. Yeah.
Don't give it to him, sir.
Sir, he was struggling to stick 2 sheets of paper together, sir.
Some more you need? Enough?
Sir.
He is very late, so.
Sir.
First come, first serve.
Enough?
Make a bigger one.
Yeah, okay.
Sir, please.
So give him less, sir.
Less is more.
Like when you were saying.
Yeah. See if it is enough.
Hold it like this or normal?
See if it is enough. Oh, okay. You be careful. Hmm? See if it's enough. Is it enough? Just hold with your hand at the bottom, Ah, okay. It's better the other way around. Yeah, that's a panicky stuff. Yeah. Take it out. Who else needs? You already have? Already have? Yeah. Tie it nicely. Okay. That's additional for you. Over, huh? Anybody needs more? Anybody needs more? A little bit more? Yeah. You can perfect it later. What we are doing is a hard one and a soft one. Okay, my part I am going to wrap up. There are many other things that I wanted to show, but I'll just wrap up with a couple of things because the next professor will come. He will scold me. He or she, I don't know. But no. Can I? Okay, watch this. What are these? Magnetic balls, right? I have made a ball now out of the magnetic balls, nicely. And when I drop, earlier I dropped, no? When I drop, what should happen? Bounce. Scatter. It will deform, but it will be intact. Not like the other ball that I showed you. The other day I showed, no? No, huh? Yeah. How many feel it will deform? How many feel it will bounce back? How many feel it will spatter? Let's find out, no? Yeah? Again. I can stand on this. Thank you. That's enough. Yeah, enough. Yeah, okay. I can stand on this. Nice view here. How much bounce do you expect? 0. This deformation we call as plastic deformation. Plastic in the sense that it absorbs the energy. The kinetic energy here ideally should bounce. So this ball is very similar. Come. We are waiting for you. How are you? Okay. No, they asked me to stand up on the bench. Clear? So we created a flexible ball. We created a stiff panel. Alright? We will continue the next day. The other professor is here. Yeah? What do you do with that? Play with that. Ball means play with that, correct? Alright? See you on 30th. Okay. What did we learn today? Quickly, number one, material can be flexible, stiffness. One, freeze. Wow, good. No, the freeze. One property that we learned today is specific stiffness. What could be the unit that I can use? What is flexible? What is flexible? What do you mean by flexible? It bends easily for the same force. If I apply the same force, it bends a lot more if it is flexible. It bends less if it is stiff, correct? Yeah? So it has to be force per displacement. Wonderful. So that's what we learned today. Okay? Thanks, folks.